Hi everyone, today we're going to talk about the sum of an arithmetic sequence. So let's just begin with a fairly straightforward little sequence here. Let's imagine we had a first term equal to 2 and we had a common difference of 3. Now let's say we want to talk about, 5 terms of this sequence. So we could write the sequence. We start with 2, add the common difference, we have up to 5, add another 3, we're up to 8, then 11, then 14. There's our 5 terms. If I wanted to add these terms together, rather than just have a sequence of numbers, if I want to add these things, then I will call this the sum to 5 terms. Now, I could add them up, but imagine I had a much larger example with a much longer list of terms. That would become very tedious very quickly. So this is the trick. Now, we write the same numbers in reverse order. And of course that also equals the same sum to 5 terms. Now we're going to add downwards. 2 plus 4 is 16. 5 plus 11 is 16. And this is twice the sum that we're looking for. Now, this is much more easily expressed. You might have noticed that this was the first term plus the last term of the original sequence, the 2 and the 4. Now the next one is also, because we've increased this one by a common difference but we've decreased this one, it compensates. The next one would have to be the same as the first term plus the last term, all the way along, equals 2 times the sum to 5 terms. Now how many of these were there? Well, there would be the number of terms we were interested in. N times T1 plus Tn, the first times the last. Divide this by 2 and that gives us the sum to n terms. Now I didn't actually figure out the answer, I was using that as a little example of where this rule comes from. So that's how we find the sum of an arithmetic sequence, and we call that a series. So I'll give you an example. If we go with the one we had there, 2, 5, 8, and so on. So if I was to do a value for n, the term, and now the sum. So these just go sequentially, 1, 2, 3, 4, 5, and so on. Remember we had the first term a equaled 2, we had a common difference of 3. So Tn, that's our sequence. So 2 and 3 are 5, 5 and 3 are 8, 11, 14, and so on. Now, what about the sum? Well, the sum to one term is just the first 2. The sum to 2 terms is 2 plus 5, that's 7. The sum to 3 terms is 7 plus 8, that's 15. The sum to 4 terms is 26. The sum to 5 terms is 40. Now be very, very careful. This is the sequence. We already knew about that. These numbers are called a series. Now they're not arithmetic anymore. They don't jump up by the same amount. That one's jumped up by 5. That one's jumped up by 8. That one's jumped up by 11. That one's jumped up by... So this is not... this is called an arithmetic series, and we find these by the sum of the terms in the arithmetic sequence to n terms. And remember, we don't have to work one by one by one. We can jump ahead to any place we like using the formula we just devised. So if I wanted to find the sum to, I don't know, let's say 30 terms. Now at the moment you might think I have to work all the way out to 30 and then add them all up. Remember we had n over 2 by the first term plus the last term. Well, let's get a little bit fancy here. N over 2, first term. Didn't we have a rule? Didn't we have a rule previously for predicting the nth term of a sequence? Wasn't it the first term plus n minus 1 times d, the common difference? So why don't we put that into our formula? So the first term plus n minus 1 times d. And this gives us the alternate version. 2 times the first term plus n minus 1 times d. So if I did want the 30th term in this series, I'd have 30 over 2 times, now what was my first term again? My first term was 2. There it is, my first term was 2. My common difference was 3. So T1 is 2 plus 30 minus 1. The common difference was 3. That's 15. 2 2s are 4. 29 times 3. I think that's a job for the calculator. 15. What have we got? 4 plus 29 times 3. 1365. Grows rather rapidly, doesn't it? So if I were to list all of these out to the 30th term, add them all up, I would get the answer 1365. So there's a couple of important points here. If I just write Sn in here, this can be used as a formula for the sum to n terms of the arithmetic sequence. Remember, we call that new list of numbers a series. So that would work. And of course we also had from up here this one, term 1, first term plus last term, n over 2 at the front. So we still have the n over the 2 at the front, and this is the combination of first term plus last term when using our previous formula. That's enough for now. I'll see you in the next video.